All right, I bet you're excited. We are going to go into graphing lines. Now, before we start doing lines that look like that or maybe like that, we're going to start with the basic ones that look like this and this. What's the difference? Well, this is assuming it's perfectly up and down, and that's perfectly side to side. What do those lines look like in a graph? So here's a typical kind of thing. A vertical line, how do we get a vertical line? So if this was our Cartesian plane, a vertical line would mean that we had, let's say, like an infinite series of points up and down forever and ever and ever. Okay? Now, in order for these to all be exactly in a perfect line, it means that if this guy is that far away, then it means that that one is the same distance. The same distance away, and this guy is the same distance away, and this guy is the same distance away. And what that tells us is that every point on this dotted line, which looks like a regular line because there's so many dots, every point on this blue line is exactly the same distance as every point on our y-axis. Oops, our y-axis. So what that tells us, we can summarize every point with one phrase. The horizontal displacement of every point on this line equals some number. Now let's say that was like 1, 2, 3. Let's say, so I put a little 3 there, 4 is over there, 5 is over there, 2, 1. 1, 2, 3, 4, 5. Let's say it was exactly 3 units to the side. Every dot on this blue line has a horizontal displacement of positive 3. Because every dot is exactly 3 units to the right. Likewise, let's say I had a line over here that's supposed to be straight. And let's see, so 1, 2, 3, 4. Let's just say that's -4. -3, -2, -1. This line is at -4. Okay? So this x equals positive 3 belongs to this line, and over here the equation, and that's the actual equation, the equation of this line would be x equals -4. Why? Because every point on this line, every dot of the infinite dots that make up this line is exactly 4 units to the left of my y-axis. 1, 2, 3, 4 to the left. There you go. So that's how you do vertical lines. Now the good news is that horizontal lines are the same idea. So you really only have to learn one idea here. And horizon, think of, there's the sunset on the horizon. Horizontal lines meaning we're going left to right. Okay. So here is our Cartesian plane. Make sure you have your y and your x on there somewhere. Let's say that you had a line over here. And this was, oh, watch this. Let's say this was 5, 10, 15. Yes, you can skip count. Sometimes your axis line, this is called an axis line, sometimes that'll include skip counting. That would be -5, -10, -15. Okay? So this line right here is, if you just look at the graph, you'll say, well, that's 5, 10, 15 high. So instead of saying x, horizontal displacement, we're going to say vertical displacement. This green line has been lifted off of the ground, how high? 15 units, 15 feet, whatever it is. Y equals positive 15. That's the equation of that line. And what this means is that, just like how x was horizontal displacement, this is vertical displacement, meaning that's how high we've lifted it off the ground. That's how you do vertical lines and horizontal lines. All we're saying is how far are we moving to the side, or how far are we moving up or down.